Hello and welcome to SudoKanard. We're here to solve this factor line Sudoku by Turkish author Salih Alan from the latest Sudoku Grand Prix. And this variant is, I think it's new on Sudoku Grand Prix, I'm not sure, but uh, I'm pretty sure I saw it already on another contest, but I just can't remember where it was. The special rule here is that whenever two cells are linked by a segment like this, then one of the digits must divide the other. So this is the only special rule, and you can see that there are not that many clues, and we have to do with that. I solved it during the contest, but I realized too late that I had made a mistake, and I hope I won't make a mistake in this video. So place to start is definitely such a long line. And something you'll get to appreciate is that some digits have very few digits they can be connected to. Namely, 7 on such a line would necessarily be accompanied with a 1, like this, like this. This is the only possible neighbor of 7, and the same is true for 5. And placement of 5s here is important, and 5 and 7, because we know that 7 can't be in here. So is 7 somewhere along the line or in this cell? If we try to put 7 along the line, then it must have only one neighbor, which means that 7 has to be here, and its neighbor must be the 1, but it's not available. So 7 is not on the line. And something similar is happening with 5 on this line, because now 5 can't be here. It could be here or it could be here, but with a neighboring one, which is not available. So the geometry is similar, and 5 is here. Now we know that 5 is somewhere along this line, and it will be on one end accompanied with the 1. So the only place is here. And similarly, 7 must be on one end, but here it would be with the 1 with the same problem, the same issue as aforementioned. So the 7 is here with the 1. So this is a place to start, and I think I remember that the rest is basically forced, because now 9 can only have 2 neighbors, and it can't be here. So the only 2 neighbors of 9 are 1 and 3, the only digits that are divisors of 9. And we know that 9 is not on this end, so 9 will be somewhere surrounded by 1 and 3, so 9 is here with the 3. We are left with 2, 4, 6, 8, and 6 can only be a neighbor to 3, well actually, let's put it this way, only 6 can be a neighbor of 3, now that 1 has already been used. And the only other possible digit of 6, the possible digits of 6 are 1, 2, 3, so that's a 2. And now 4 and 8 need to be disambiguated at some point later. And something similar is happening here. 9 can only be a neighbor of 1 and 3, so 9 could be here or there. So we could have 9, 3, sorry about that, 9, 3, 6, 2, and 4 and 8. This is definitely an option. 4 and 8 would be disambiguated in this scenario, or 9 could be on the other end with 3 here, and then it would have to be 6 and 2, and then necessarily 8 and 4 in this order. So that's an option, and the other option was a 9 here, 3, 6, 2, and 4 and 8. So those are the two options for this region. Now let's move on somewhere else. So I'm thinking that this and that should be places of interest. Definitely. This could also be a place of interest. I'm thinking that the location of 7 in this box should be interesting. So where could 7 be? 7 can't be on that square because it would need to have 2 neighbors, and 7 can only have 1 neighbor, so 7 is here. Where is 9? 9 along this line would have 2 neighbors, 1 and 3, so 9 could be here with the 1 and the 3, and this would have to be a 6. With 2 and 8 here, it seems to work. Or 9 could be somewhere else. That's not saying much. Perhaps it's not the place to look at this point. So what do we have here? So the options are 2, 3, 4, 6, 8. So there seems to be quite a number of options. Yes, perhaps I'm saying that 5 must be here, and it's this. What did I do? I removed the 7 where it belonged. Oh, yes. So we saw that 7 had to be here. I'm thinking that 5 has to be here by the same logic. 5 can't be anywhere along the square because it would need 2 neighbors, and 5 only has 1 neighbor. And because of the 5 here, that's the 5. Definitely. So now we have a 5 down there. We have a 7 up there. So here, what about this square? So there are quite a number of possible digits. Actually, seeing those here must be from 1, 2, 4, 8, and this is not a 4, which is quite interesting, because obviously 3 would only be neighbor to 1 along those lines, and we would have a 6 and a 2 here, and 4 and 8 here, and 4 there. So one option is, say, 1 and 3 here. So 3 would be neighboring 6, and 1 would be neighboring 2. So we would have 2 and 6 like this. And then 8 and 4, this would have to be 2. And we would be left with 6 and 3. So that totally seems to work. But if it's not 1 and 3, so if 3 is not in there, we are left with digits from 1, 4, and 8, and because of this, 1 has to be in there, with the 4, 8. Let's say this is 1 and 8, then these will have to be something like 2 and 6, perhaps, or perhaps 4 and 2, so there are quite a number of options. I don't remember. That there were so many options. Oh, those ones tell us that there is a 1 in here, which is not saying much because 1 could be a neighbor of any digit. But I'm seeing that 2 and 6 do not belong in here. So they could be there. I'm also seeing that 8 is somewhere in here, so 8 is not there. So what are the options for those cells? We've excluded 1, 7, 4, 5, and 2 and 6. So they are from 3, 8, and 9. And that's interesting because 8 would never be a neighbor to 3 or 9. So those are 3 and 9 definitely. So that this is 4, and this is 8, and this is 2, 6, 3, and 9. So this is completely disambiguated. And then the second, well, 9 won't be here because of this 9. So this is 3, this is 9. The second neighbor of 9 is 1. And the other common neighbor to 1 and 3 can only be a 6. All right, so there was something to do in here. Those are 2 and 8. Up there we get 8 and 5. Here we get 2, 7, and 9. So this is 9 with a 2, 7 pair. We're left here with a 3, 6, and 4. And because of this 4, this can only be 3 or 6. So the only possible neighboring pair is 2 and 6. This is 8. We're left with 3 and 4. Only 3 can be a neighbor to 6, and this is it. Nice. Now, neighboring 3 without being 1 or 9 has to be 6. On this row, we are left with 2, 7, 9, and 3. So this can only be 2 or 3. On this row, I need digits from 4, 5, 8, with 4 being in here necessarily. And now this is interesting. If this is 2, then 1 and 8 are possible here. If this is 3, knowing that 6 is not available, only 1 goes there. Right. This row still needs 1, 2, 4, 7. Oops. 1, 2, 4, 7. But this is not 1, this is not 7. So this is 2 or 4. And this can't ever be 7 next to 2 or 4. This one is here, so this must be an even digit. Because of that, this is from 2 and 6. And obviously, one of them has to be a 2, because 4 and 6 can never be neighbors. So one of them is a 2. So this is not 2, 4. This is from 3, 6, and 8. 2, 3, 4, 6, 8. So this is from 2, 4, 8, which is kind of interesting, because now we know that those 3 digits cannot all be a 2, 4, 8. There has to be a 3 or a 6 in there. So it could still be 6 here, 2 and 4. What was I saying? 3, 6, 2. It could be. Well, I'm not sure this is the right place to look. Oh, what I'm saying is that on this row, 1 is around here, so that this is 8, and this can only be 2. So that's 7, that's 2. 2 and 7 are removed from here. 2 is removed from there. 8 is removed from here. So those can't be 3 and 6. And actually 3 can't be anywhere in here. So that's the 3. And 6 is somewhere here, accompanied with the 2. What am I doing? If I try to put the 6 here, then this is 2, and 4 and 8 remain here. None of none of whom can be a neighbor to 6. So that's the 2, that's 4, that's 8, and that's 6. And its neighbor, 1 and 2 are not available, so the neighbor is 3. That's 9, that's 3. Neighboring 3, it could be 1 or 6. Those are not 4 anymore. And, well, everything is possible in here. Let's move on to this part. Actually, seeing the 2's, that has to be a 2. And seeing this 8, that has to be 8. So this is 4, this is 8. And those are 1 and 6. So 6 can only be made, well, just by Sudoku. This is 6 and 1, but the divisibility relationships tell us as much. This 9 goes there, and this is 5. Here we need 3, 4, 6. So 3 can only be here. So we are getting there, I think. That's not a 5. So basically all that is pertaining to the variant has been done, so the rest should be plain Sudoku. Here we need 1, 5, and 4, so this is 4. Those are 1 and 5. Here we need 3, 7, 9, so this is 7, this is 9, this is 3. Here we need 7 and 8, so this is 7, this is 8, that's 1, 2, 7. 1 and 6 both work with the 2 and the 3. This row needs a 9, it can only go there. This is from 1, 5, and 6. Down there I need a 2, it can only be here. This column needs a 4, it's not here, it's there. This is from 1 and 5. There's already a 5 in the column. This is 5, 4, 6, this is 8. That's 4, that's 5 and 8. And we're left with 1, 5, and 7. So there was definitely some work to do in the beginning. But all in all, this was really a nice puzzle. Really a good use of the constraint. And in spite of the low number of clues available, it did so. So 67 points may have been a little underrated, I think, considering the difficulty. Well, all in all, thanks for watching this video and see you soon on SudoKanard.